Okay, so where are we? There we go. Now we're going to deal with radical expressions. First we'll simplify them, and then we'll talk about a special rule regarding them when they're in fractional format. First, to simplify them. So these are square roots, okay? You could change these to fractional exponents if you wanted to, but this book wants us to keep the in radical format or in square root format. So to simplify a radical, basically it's handy, you don't have to if you break things down into a prime factorization. I'm not going to break it down into prime, but you definitely can. I'll just break it into simple things that I know have square roots, and that will help me simplify these radicals. And I'm going to remind myself that these are square roots versus cubed roots, fifth roots, things like that. So I'm going to go to my first expression and look at it and say, ooh, the square root of 9 is 3, so that goes on the outside, and I've taken care of the 9. On the inside, I still have a 2 left because 2 does not have a square root. The m, there's 3 of them in here, and I'm looking for groups of 2 because I'm looking for square roots. Another way to look at it is this is saying m cubed to the 1/2 power, or m to the 3/2 power. So basically you're dividing by 2, which is what I do. I say, well, 2 will go into 3 one time, and there would be 1 remaining, right? That's one way to do it. Another way is to list out the 3 m's inside the radical. You're looking for groups of 2. You found one group of 2, so that grouping of a single grouping goes on the outside, and you have 1 remaining. Okay, here we have 3m, and here we have a square root of 4, which is 2. That goes on the outside. Square root of 4 is 2. That goes on the outside. And what's left on the inside is 2m. Can't do anything with those things, right? Over here, 5's on the outside. Again, 2 will go into 3 one time with 1 left over. I'm making division symbols instead of square root symbols. Okay, once you do that, clean it up a little bit. I'm going to just simply clean up my outside pieces. 3 times 2 times 2, which is 3 times 4, which is 12. And don't you know what, I'm forgetting my pieces here. Okay, ooh, looks scary. Hopefully you're following along. Combine your outside pieces if you can, if the bases are the same. The bases means the stuff inside the radical. So I've got 2m and 2m here. I can combine those terms to get a negative 9m on the outside, and on the inside I have 2m, right? Now this guy, he has a base of the square root of m, so he cannot combine with anyone, so we need to just bring him along for the ride, so to speak. So that's combining radicals. You treat your radicals a lot once you have simplified them into their very base form, the simplest that they can get. Once you do that, you treat them like variables, like regular letters, like you do x and y. Okay? You combine like terms in the same fashion. Now, another thing about radicals is someone somewhere said that you can't have them in the denominator. So if they're in the denominator, you get rid of them. A great way to get rid of a square root is to square it or multiply it by times itself. In this example, this is a very common example, you have a radical in the denominator, but he's a binomial. Okay, so he's attached to somebody, particularly this 3. To get rid of a binomial expression, you can multiply by words lose me right now. Sorry, I have a headache. The conjugate. Multiply by the conjugate. What this does is we create a difference of squares. So to create a difference of squares, I would need, the missing piece would be 3 plus the square root of 2. That's called the conjugate. But what you do to the bottom, of course you have to do to the top. Okay. Multiply across the top, distribute your 6. Or don't distribute your 6. You can save that for later. Right? Save the good stuff. On the bottom, put your denominator pieces in parentheses to remind yourself that you're foiling. You're multiplying binomial expressions. So to FOIL these together, we'd have 9 plus 3 square roots of 2 minus 3 square roots of 2 minus the square root of 2 squared. Okay? And that's important. Working on the top still, you can distribute the 6. This book is leaving it on the outside the whole time for some reason. I don't know why. Whatever. We'll do the same. On the bottom, your inside pieces are going to cancel. So we have 9. We have a minus sign. And we have the square root of 2 squared. That's saying the square root of 2 times the square root of 2. Which is basically 2 raised to the 2 over 2 power. If you're doing fractional exponents, they cancel. Okay, square root squared, cancel, you're left with what's inside, which is just a 2 in our case, because that's that number right there on the inside. Simplify it a little bit more. Again, you can distribute this 6, but some books would make you undo it if you want your answer to match the back of the book. 9 minus 2 is 7. So this is an acceptable answer, and that's the answer that's in the back of the book. Another answer would be 18 plus 6 square root of 2 all over 7. That's also acceptable. Sometimes your answer is fine, it's equivalent, but it doesn't quite match up to the back of the book, and that's nothing to be alarmed about. Remember, they can't get all the different variations. They try to just get the one that is most simplified or most mathematically proper.